Alright, so I'm going to go through and try and do some of these constructions for constructions 5 through 7. So that's just the ones I'm doing right here, 5 through 7. That's the second worksheet that I went ahead and put on Google Classroom. Hopefully you find this to be helpful, and hopefully this video is better than the other one. So for first off, going through some of these questions, just want to kind of talk like, what is an arc exactly? Well, an arc, a lot of people are having trouble with that, and that's really just where you take and you have part of a circle. That's what an arc is. If you talk about what a diameter is, that's the line that goes through the center of the circle from one side of the circle to the other. It has to go through the center and go all the way across the circle. For a radius on one side of the circle, when I talk about going around in a circle and spinning and turning that radius, it's basically like you have a steel bar attaching you to this middle pivot, and as you go, that steel bar is not going to allow you to go further out. It's not going to allow you to come closer in. You're going to have to stay on that perfect track around. So the radius is constant, and to be inscribed, something kind of asking about, that's when your vertices are all on the circle. Sorry, so all your vertices are on the circle, and on top of that, you all of your sides are inside the circle. So the entirety of the shape is inside, and the vertices, which would be like, you talk about a corner of a shape, would be on the circle. And then what is an equilateral triangle? Hopefully you guys know this one already. It's just trying to refresh it. And that's just a triangle where all three sides are the same length. Equilateral means all three are equal length. And it also is equiangular or equiangular, depending on how you like to say it. And in that case, we really or in that case, with an equilateral triangle, we're really trying to talk about not only sides but also angles. All the angles are the same, which means they're 60 degrees. So without going any further into that and let you guys kind of delve into that on your own, you have an inscribed regular hexagon. And for this, it says in the steps, first step is always to do a center point. When you do a center point, I want you to make that point as small and fine as you can. Alright, if you make it very, very big, what happens is I can have a little bit more movement and still stay on that. The smaller my point, the more precise my construction is going to be, which means it's not only going to look cleaner. I mean, that's one thing that'll happen. It'll look nicer and cleaner, but it will also end up being more accurate and more precise. So that's my point A, and I'm doing a regular hexagon. So what I need to do is I need to go ahead and set my compass on point A, and I make sure that it's set where that dot is perfectly in the center. And then I'm going to pick a spot out here. Now you notice I have this one shaded. That's just because I use it a lot and I like it. So I'm going to take and draw a circle using that. Now, key thing about drawing a circle, some people are having trouble with that. Make sure you're putting pressure down. Like when I move this paper or I move this compass, the paper moves with it. If I turn it, wherever my fingers go, the compass moves the paper through friction. So I am keeping everything together and tight. The only thing that moves is this blue piece on the outside of my compass. Then, to do a diameter, what I am going to do is I'm going to take my colored pencil here, in this case, I'm going to set it on that center and then set the straight edge against it. The key thing here is notice how, like when I look right here, that dot is not touching here. If I were to do that and then draw my line's going to actually be somewhat off to the side. So I want to go ahead and put my pencil or pen down on that mark first to line up my compass. It does not matter what angle you're at, because whatever angle you're at, the diameter is simply going to be any line that goes from one side to the other and through that center. So as long as it goes through the center one and starts on one side and ends on the other, this is a diameter. We go ahead and name those B and C. And then from here, we are going to take our compass and we're going to place the center at B And with my center at B, I'm going to double check my radius. I just stress, always double check your radius, make sure you have the correct thing. As I draw it, you can tell it goes through A. So that's the one I want. And I'm going to draw an arc that intersects the circle twice. Notice I'm not drawing a full circle. A lot of people are getting confused just drawing a full circle. If you do a whole bunch of extra stuff, it's going to make it really difficult to be able to keep track of what you're trying to do, because you're going to have a whole bunch of stuff and you create a little bit of chaos on your paper. So I have this. I go ahead and name these points. That would be D and E. And now I'm going to repeat the process, but from C. So I'm going to come down to C. My center is at that point C where the diameter intersects the circle. I come back, I double check. Listen, I know that that's going to match up. I know it because I haven't changed where I'm at. But I'm double checking just to make sure I'm accurate and just to make sure I'm at the right location. And so you should have something that looks, I don't know, similar to a basketball. And these points from this arc, these points will be F and G. Well, to finish up, all we need to do from here is just connect the dots around the circle. So B to D, F, C, G, E, and then back to B. So I'm just going to go ahead from B to D, D to F, and F to C, from C to G, G to E, and then E to B. And then you can see this blue line. If you're colorblind, I apologize. But this blue hexagon has been formed inside. It's inscribed because all the vertices are on the circle and all the sides are inside the circle. Alright, so that's an inscribed hexagon. Next up, we have a 6-point star. And this construction is going to actually be almost identical to the one above it. It's almost the same exact process. It's just the final step is going to be different. So we're going to start out the same. We're going to create a point A. It's my point A. I'm going to take my compass. I'm going to set it on A. And I'm going to draw a circle. From there, I'm going to go ahead and set my pen or pencil on A, press my compass up against it, and I'm going to just go ahead and go right like that to create my diameter, which gives me B and C. And then I repeat the process of putting my center at B, double check my radius to make sure I'm correct, and then I come down to the bottom and repeat the process with my center at C. I double check my radius once again, and then draw my arc. And then, so these were D and E. These were F and G. Now we get to our one difference. And that one difference is B is going to skip D. It's going to go straight down here to F. Alright, so we are going to go ahead and take from B to F. Then F is going to skip C and go straight to G. So from F to G. And then to finish up, G back up to B. We're going to skip E, G back up to B. So we have this. There's FG. So there's the first triangle. If you notice, I still did this part. We're not just doing an equilateral triangle, we're doing a star. So what we're going to do now is we are going to do the same thing but from C, and C is going to come up to D, D is going to come over to E and C. So they're skipping points. So C to D, D to E, and then from E down to C. And what you notice is we have 6 points on the star, and in here, of course, you have a hexagon inside it, but this is a 6-point star, all the vertices on the circle. Some people might ask, like, hey, how would you do a 5-point? How would you do a 7-point? Stuff like that. There are ways to do it. It's just those constructions are more complex and they take a little more time to complete. And we've got to be able to do constructions like this before we can build up to those other ones, such as a star with 5 points or something like that, like you might see on the American flag or something of that sort. Alright, now last but not least, we have an equilateral triangle using a given side. Oh. There we go. So an equilateral triangle using a given side, and this is, we're getting away from that circle start, and in this case we're going to start with a segment, and you're going to be given a segment. So come in, you're going to be given a segment A, B. Alright, that's just what you're going to start with. You get your paper, it will have that there. Well, to do this, it's actually quite a simple construction. I want to make it where I find some point either above or below, one or the other, so I just need one side, where this line will be the same length as the existing line we have, or segment. This segment will be the same length as this segment, and then this segment will also be the same length as the existing segment AB, as well as the other one. Well, to do that we use circles, and we're going to use the circles and use this arc. So here I find my mark. Now mind you, it's not exactly perfect. Alright, the point's kind of in between. So in that case you get a little bit of mercy. You get to go with the closest one, which I'm choosing this one. And I need a different pencil to do that. And what I like to do is I actually like to kind of abuse my compass for a minute. And I'm going to make a mark here so that when I move it, I can see that little black mark there. And the great thing about it is you see it down here, is as long as I'm not crazy about it, it will erase right off and it won't damage anything at all. So I set my compass up, I find that mark, and I go ahead and draw an arc to one side. And it says on the paper you can go up to a semicircle, which would be half a circle. Really all you need is like right to here. That's really all you need. What I know is that every point, like if I drew a segment, every segment from point A to this arc is going to be the same length as segment AB. I know that because it's a radius, and the radius is constant. It cannot change. The other thing I know, or the other thing I need to do next, is I need to come in here. I need to take point B. I put my center on B. Once again, I double check my radius. I know it should work, but I double check it to make sure it does. And then from there I draw an arc out, and it just needs to intersect, because I mean really the excess stuff isn't necessary, and it's just extra stuff to make things a little bit like less clean, I guess. That point up there, we're going to call that point C. And here comes the easiest part of this whole construction, and that is you just go ahead and connect A to C. I know that AC has to be the same length as AB because of the fact that they AC is on this arc, right? It's a radius of this arc. And if AB is a radius of the arc, AC is a radius of the arc, then they both have to be the same length because the radius cannot change. Same thing with B. BA is a radius of this arc. And if BA is a radius of that arc, and BC that I'm about to draw is the same length because it's a radius of that arc as well. So I go ahead, come in, look at that, I draw it, and there, I've gone ahead and constructed triangle A, B, C, and it is equilateral. And that's all I need for the equilateral triangle. So guys, Hope this stuff helps you. I hope this video is much better quality than what I had the other day. And let me know if you have any questions. Alright, enjoy.